I'm going to go through one of the trickier questions from the homework on integration, mixed integration. This is question 8. Okay, so you're given a diagram with a curve and a tangent. So we're told the curve is y is x to the 3 over 2 minus 1, and it crosses the x-axis at 1. Put that on there. And the tangent to the curve at the point 47. The first part, we just have to show that this integration gives us 9 2/5. So the integral, so this is part 1, from 1 up to 4 of x to the 3 over 2, take away 1 with respect to x. Okay, so the first thing we do is we raise the power by 1, we divide by the new power, which is the same as timesing by its reciprocal, and then when we integrate 1 we get x. And we have to evaluate that at 4 and 1 and subtract. So to get the marks, we just substitute in 4. Okay. And then we take away the same again, but substituting in 1. All right. And then we can type it on the calculator. So we've got 2/5 times by 4 to the power of 5 over 2. Okay, minus 4. Oh dear. Okay, so that's 44/5. Take away. And if we substitute 1 in, we're going to get 1 to the power of anything is 1. So we've got 2/5 take away 1. So that's going to be negative 3/5. So altogether we get 48/5. Oh no, 47/5. And 47/5 is indeed 9. Okay, and 2/5 left over. So that's done. Okay, you can always check on your calculator wherever you like to. Okay. For the next part, this is a bit trickier, hence. So we have to use this answer to find the exact area, so we need to work with fractions, of the shaded region enclosed by the curve, the tangent and the x-axis. So let's just look at how we can get that shaded area. So we've just worked out the integral from 1 up to 4, okay, of the curve. And that would work out this whole shaded area, which is the curved bits, the area between the curve and the x-axis. Okay, so we know that that is 47/5. Okay. But if we then take away this bit that I'm making stripy, the triangle, then we'll be left with the bit that we want. Okay? So the key thing is we need to work out the triangle. We know the height of the triangle is 7. Okay? We know this is 4. We don't know what the width is because we don't know what where the tangent crosses the x-axis. So that's what we're going to have to work out. Okay, just for completeness, show what that works out. Okay, so the triangle. So we need the equation of the tangent. We've got the point, so we need the gradient. I want the gradient of the curve at 4, 7. So we want dy by dx when x is 4, okay, and y is x to the 3 over 2 minus 1, so we bring the power down and we reduce the power by 1. You have to be very careful not to mix up integration and differentiation. And then when we differentiate 1, we get 0. And we just substitute in x is 4, so we've got 3 over 2 times the square root of 4, so that gives us 3. Right, so equation of a straight line, y minus y1 equals mx minus x1, where m is the gradient, and our coordinates, our y coordinate 7, okay, gradient 3, x coordinate 4. Okay, so we just want to know where does that straight line cross the x-axis, and that's when y is 0. Okay, so I'm going to divide by 3. And I'm going to add 4. Okay, so that's going to be 12, take away 7 is 5/7. 5/3 is x. Okay. Okay. Right, so x is 5/3. You can't quite see it on the screen there. Right. So 5/3 goes here. So now we can work out that distance. So the area of the triangle is going to be a half times the base, 4 minus 5/3, times the height, which is 7. Okay, so that's 47/5 take away. Let's have a go on here. So a half times by 4 take away 5/3 times 7. So that gives us 49/6. So if we do 47/5 take away 49/6, we get 37/30. So that should be the exact area between the curve, the tangent, and the x-axis.